Okay, so we are going to start with our next lecture. Today's lecture is about class diagram, right? So when we talk about class diagrams, I have already told you in the earlier lectures that is we have diagrams which are in UML, and these particular diagrams are basically broadly categorized into two, which is termed as the first one, the behavioral diagram, and the second one are termed to be as structural diagram, right? Now, behavioral diagram are according to their behavior, so they are termed as dynamic. These are dynamic in nature, right? These are dynamic in nature. While when we talk about structural diagram, these particular are static in nature. When I say static in nature, because they are not going to change according to the time. That is why they are the statical view of the concept. Now we are going to firstly understand that is the first diagram we are going to do. We are going to do all the diagrams. The first diagram we are going to do is the class diagram. Now this particular class diagram falls under the category of structure diagram, right? This is coming under the category of structure diagram. And when we say structure diagram, so I already told you that this is the static view of the concept of the software. So class diagram is considering under the category of structural diagram. Now we are going to understand what is class diagram and how do we, draw these particular class diagrams. See, when we say class, we all know what is a class. Class is a concept, right? It is a conceptual thing, that is an abstract thing. When we say class, we graphically represent it in the form of a rectangle. Now this particular rectangle is divided into three parts. The first one is termed as the class name, the second one is termed as the attributes, and the third one is termed as the operations or methods, we can also call it as. Now we have already understood what are classes in our earlier lectures. How do we describe the class? What are the examples of the class? So firstly, we are understanding how we are going to draw this particular class diagram. Now, when we see this particular rectangular box, this has three divisions. The first division will have the class name, right? The second division will have the attributes, and the third division will have the operations. Now we'll see what are this class name. Now when I say, let's take an example. If I say that we have a class called, vehicle, right? We have a class called vehicle. Now, vehicle is what? Vehicle is just a concept. It's a abstract form. It does not have any data, right? But until and unless we give the example or we give an instance of this class, example car, example car. So this particular can be termed to be as the instance of the class vehicle, right? Because this will have data, the name of the car, the color of the car, and so on and so forth. So we have to define first of all the name of the class. So when we say name of the class, name is to be required and to be defined in this rectangular box at the topmost compartment here, right? We are going to define the class name. Let's say vehicle is the class name, so I'll just give the vehicle name out here, that is vehicle. Okay, now second one is the attribute. We all know what are attributes. Let's say I have taken an example of person. I have given the class name as person. I have taken the example of class as person, and now what are the attributes of this class person? The name will be there will be an address, there will be birth date, and there's an SSN. SSN is just a unique identification number of the citizen. It is used in US. So basically we have these four attributes of the class person. Now these are what? These are the properties of the class. This will be stated in the second compartment, the highlighted one, right? So in the first compartment, there will be the name of the class. In the second compartment, there will be the attributes of the class. Now, when we say attributes of the class, we have also need to define the data type according to the, you know, the attribute we are using. If we are using name, the data type we are giving the string. Address, we can also give the string. Birth date, we can take the date. Now, in this format, we have again different ways in which we can show the attributes. That means you can just see out here, that is at the age there is a slash out here, right? What does this slash denotes? Actually, the slash denotes that this age attribute is a derived attribute. How it is a derived attribute? When we know the birth date, we can derive the age of the person. So this age attribute is derived from the attribute birth date. So that is why this symbol, that is slash, is used, which is defining what this is defining, that this particular attribute is going to be a derived attribute. Okay, so similarly now we are going to define what we are going to see, that there are other types also through which we can denote what type of attribute is the one. See, plus sign is there. When plus sign is used, it means the public. What does it mean when I say public? Public means to say that this particular attribute will be visible to all, right? This is public. When I say public, I mean to say this will be visible to all. When I use this hash sign, this hash sign is going to show that this attribute is the protected attribute. When I say protected, that means it is visible from within the class and from the subclasses inherited from this class, but it not from the outside. It will not be visible from the outside, but it will be visible from the class which are also inherited, right? Then we have the third one, that is the private. Now what is this private showing? Private is only visible from within the class. It cannot be accessed from outside the class. If there is another class, we cannot access this outside the class. It can only be accessed in this class. So public means view to all. When I say protected, protected means that it is visible from within the class and from the subclasses inherited from this class, but not from outside. And lastly, the private one, which is what? Which is visible only from within the class. Okay. And lastly, the derived, we have already seen derived. What is it? If a particular attribute is coming from the another attribute, that is a derived attribute. Okay, so these are the four signs we are using. So see, name, we can make this name of the person as public. It can be seen from all. Address is protected. It can be only be seen from the inherited classes and subclasses. Same with the birth date. Age is a derived class, but SSN is the unique identification of the person. So we are making it what? We are making it private. It will not be visible from outside the class. So this is how these particular notations are being used when we define different types of attributes in the class. Now moving further, the third compartment we are going to see is the compartment which is used for operations. Now operations are what? These are the operations are what? These are the class behavior which are being shown. These are also called as the methods, which are like person can eat, person can sleep, person can walk, person can play. So all these are what? These are the operations performed by the class, and these are the properties of class. So this is the class name, person. These are the properties and attributes of the person, that is the class, and these are the operations which are being performed on the person. So this is done in the third compartment. It is also shown, I'll just tell you again, that these are shown in the empty braces form, right? So eat, braces open and close, sleep, braces open and close, and so on and so forth. So this is how a class is represented. Now this is what we have done. Person, that is the class name, birth date, age, SSN, all these are attributes, and this is what we have, the operations. This is what I was telling you, eat and resist. Empty braces will be there. So these are the operations. So this is how a class can be graphically shown. Now, there are four types of relationship, though we have already seen what are these relationships, because whenever there are classes, there can be a relationship. There is a link between the two classes which are being rendered in the diagram. So what are these? These are four types. First one is termed as the dependency. Second one, generalization. Third one, association. And fourth one as realization. Now there are, we'll see how these are different from each other. First of all, we will see the dependency part. Now what is this dependency? Dependency is saying that one particular part is dependent, one class is dependent on the other class. If there is a change in one class, the change will be reflected to the other class also. So a dependency is a semantic relation between two model elements in which a change to one element, that is the independent one, may affect the semantics of the other element, that is the dependent one. Okay, so we'll see this is rendered by the graphical representation of dashed line with an arrow. This is the dependent part and this is the independent part. The independent part is showing the arrow out here. So this you have to remember. You have to give the arrow to the independent part, not to the dependent, and it is given with the dashed line. Now you see there are two classes which are defined as course and course schedule. Now dependent is the course schedule and course is the independent one. Okay, so that is why arrow is here. This is the independent one. This is the independent one and this is the dependent part. Now whatever the changes are being made in the course will be seen over here. This is going to affect out here. So that is what the dependency is showing. Now next thing, generalization. Now what does this generalization means? Generalization is specialization and generalization relationship. That means one is a parent and the other one is the child. Okay, so this is represented with the help of solid line with a hollow triangle which is shown at the parent class. Now what does this mean? This is a parent class and this is a subclass. Example, I have taken person and a student. Now student is what? Student is a subclass while person is a parent class. It is a parent class while student is a subclass. Student is going to have all the properties of a person, and in addition to it he can have different and specific attributes also. So that means what? Person is a generalization. It is a generalized class. While when we say student, student is a specialized class. It is a specialized class. Okay. So student is a specialized class while person is a generalized class. That is why the triangle is shown out here to the generalized one. And we can see that all the properties of person will be inherited by the student, while there will be more specific attributes to the students also. Okay, so this is how we define the generalization and specialization. We have to remember how we are representing and rendering it graphically. Third one is the association. Now what does this association means? Association is what? Association is whenever there is a link between the two classes. Whenever there is a communication point. When we say link means what? That these two are communicating with each other. So we say if two classes in a model need to communicate with each other, there must be a link between them, obviously. So that is called what? That is called as association. If I say there is a class, student and an instructor, So there should be a link. Obviously, they need to have a communication point. Student is going to teach the, sorry, instructor is going to teach the student, and student is going to learn from the instructor. So this is the communication point, and this is the link. Now in this association, we have multiplicity. Multiplicity are of different types. In ER diagram also you must have seen this, how you are defining the relation one to one, one to many, many to one, and so on and so forth. Similarly, we have the multiplicity in the association also. So what is it? It is, this is how we show one dot dot asterisk. What does this mean? This means that a student has one, a student, this is student, a student has one or more. This is going to show as for more. Okay, so a student can have one or more instructors. Fine. Next one, when we have this particular point, that is, if I make this one dot dot asterisk to the student side, what does this mean? This means that every instructor has one or many students. We are talking about instructor now. We are talking about instructor, that instructor can have one or many students. But here what we were saying, we were saying that a student can have one or many instructors. Okay, so this is how the multiplicity is being shown in the diagrams, relationships. Now next one, if we have this one asterisk point here also and here also, this, what does it, this indicate? This indicates that what, a student can have one or more instructor, and an instructor can have one or more student. Secondly, we can also show the role of the object through this particular form. That is, a student learns from the instructor and instructor teaches the student. Instructor teaches one or many students. Student learns from one or more instructor. Okay, so next we have one more example out here, that is, a student can have membership. A student can have membership of one or more team. A team can have one or more students. So this is how we read these notations and denotations in the diagrams. Now the fourth one is the realization. Realization is what? Realization is a semantic relationship between classifiers, where one class specifies something and another class performs it, right? There is what? There is an example we have taken. First of all, it is shown with the dashed line with the triangle box follow, and we have taken an example of HTML parser and the parser. Now what HTML parser is, what is the one who is going to realize or implement the interface, while parser is just going to define the interface. So parser is the class which is going to define the interface, but implementation is taken place where it is being realized in the HTML parser. So this is how we define the realization. So now this is the whole scenario and summarization what we have done till now. You can see that this is the class name as the customer. We have taken an example of class diagram of video rental system, just a basic one. This is what? This is the class name, that is the customer. These are what? These are the attributes. All these are what? All these are attributes. CID, name, fine. And this is what? These are the methods. You can see here also there are two classes, video and customer. So video and customer are the class names. CID, name, is the property or the attribute of customer, and cassette ID and cassette volume is the attribute of video class. This is what? This is the method of class customer, this one, and this is the method of class video. Now we can see here plus and minus signs. What are these? These are showing the visibility of the attribute, how they will be visible. Minus was for private, plus was for public, hash was for protected, and slash for derived, right? Now what is this? This is showing the relationship. This particular part is showing the relationship, that is rents. Fine. And this is showing you the multiplicity. What is this multiplicity? The customer can have one or more video, and one video can be defined by one or more customers. So all these are what? These are the notions which we are using in the class diagrams. Fine. We have taken one more example. This example is what? We have taken the order system of an application. Order system is there. So we have class that is customer class and the order class. Now you can see there is a arrow out here, and we have one more. This is special order class, and this is normal order class. So special order class and normal order class are being the subclasses of order. These are the two types of orders we have seen, special order and the normal order. So these are the generalization. This is the symbol for generalization. You can see this one. This is for the concept of generalization. And when we say generalization, that means these are specified classes, these are the specifications, and this is the generalization. Order is the generalization. It has what? It has confirm method and close method, which will be there in special order also and special order also. See, these are there, and in the normal order also. Apart from that, you can have different or specific method or attribute in the special order, and similarly in the normal order. You can see here dispatch and receive, and here you can see dispatch. In some cases you can also, it's not necessary to define these confirm and close out here in both the sections, because it is obvious that it is being generalized, so it is going to inherit the properties of the order class. So this is forming the superclass, and these are forming the subclasses. Special order is having date and number, same with date and number. Order is having same date and number, but methods or the operations are specific here, apart from confirm and close. So this is the superclass, and these two are the subclasses which are forming the generalization relation. Now we can also see that a customer is there with the attribute name and local, which have two methods, that is send order and the receive order. While in order we have these date and number with the confirm operation and the close operation. Now what is this multiplicity is being shown out here? That is 1 and n. One customer can have many orders. When one customer can have n number of orders to be placed. So this is how we are going to define the order system application, and this is how we are going to define the class diagram. So that's all for this section, and thank you.